Hello everyone. Here in this session, I'll be going to discuss about Routh stability analysis. This is example 3, linear control systems, lecture series on linear control systems, lecture number 34. So this is example 3, Routh stability analysis. And special case 1. Example 3, special case 1. Solved example, Routh-Hurwitz criterion. Example 3. What is the example 3? A closed loop control system has the characteristics equation given by s to the power 5 plus s to the power 4 plus 2s to s cube plus 2s square plus 11s plus 10 equals to 0. This is the fifth order polynomial equation. Investigate the stability using Routh-Hurwitz criterion. So this is the fifth order polynomial equation. Investigate the stability using Routh-Hurwitz criterion. Solution. And this is step number 1. The given characteristics equation is s to the power 5 plus s to the power 4 plus 2s cube plus 2s square plus 11s plus 10 equals to 0. This is the given characteristics equation. This is the given characteristics equation. And order of this polynomial, fifth. So fifth order system. This is the fifth order systems or fifth order polynomial equation. Coefficients of s to the power 5 equals to 1 because this coefficients equals to 1. Also s to the power 4 coefficients 4, s square coefficients 2 and s cube coefficients 2, s square coefficients also 2 and s to the power 1. This is s to the power 1 coefficients 11 and s to the power 0 coefficients ultimate 10. So in this case, coefficients of s to the power 5 is 1, s to the power 4 is 1, s cube is 2 and s square is also 2, s is 11 and s to the power 0 is 10. So coefficients and order of the systems. Then necessary condition. This is very important for Routh stability analysis. Step number 2. Let us consider a system with characteristics equation s to the power 5 plus s to the power 4 plus 2s cube plus 2s square plus 11s plus 10 equals to 0. It can be stated that the necessary conditions for stability of a system are as. What is the necessary conditions? The characteristics polynomial have all the coefficients real and positive. So what is the first case? All the coefficients real and positives. In this case, s to the power 5 coefficients 1, s to the power 4 coefficients 1, s cube coefficients 2 and s square coefficients 2, s coefficients 11, s to the power 0 coefficients 10, and all the coefficients real and positive. So case 1 or step 1, position 1, point 1 satisfied. Then point 2, none of the coefficients of the polynomial is 0. In this case 1, 1, 2, 2, 11, 10. So none of the coefficients of the polynomial is 0. This is also satisfied. None of the power of s between the highest and lowest power of s is missing. In this case, s to the power 5, s to the power 4, s cube, s square, s to the power 1 and s to the power 0. So no missing power in this case. That means s to the 5, 4, 3, 2, 1 and 0. The necessary conditions are satisfied. it is to be highlighted that these are only necessary conditions, but not sufficient. So this is only necessary condition, but not sufficient. All stable systems must satisfy this condition. So this is also very important sentence. All stable conditions or stable systems must satisfy this condition. That means step bullet point 1, 2, and 3. Then, but satisfy the system satisfy all these conditions need not be stable. So this is the very important sentence. Necessary conditions statements. The necessary conditions help us to eliminate polynomials when with negative coefficients or missing power of s by visual inspection only. If the characteristics equation satisfies all the necessary conditions, it is possible nominee for examining further. So if necessary condition satisfied, then this is nominee for examining further. For stability, Hurwitz and each Routh have independently established the conditions for stability of a systems without actually finding out the roots. The criteria is known as Routh-Hurwitz criterion for stability. This criteria determines how many roots of the characteristics equation lie in the left half or right half of the S plane. So this is the very, very important point, VBI, because this criteria determines how many roots of the characteristics equation lie in the right half of the S plane. Suppose this is real axis, this is imaginary axis, positive, and this side negative real axis, and this is negative imaginary axis. This is the left hand side and this is right hand side. In this case, or this criteria determines how many roots of the characteristics equation lie in the right half of the S plane. That means this side. How many roots of the characteristics equation lie in the right half of the S plane. If left hand side roots, all the roots left hand side, then system will be stable. But if right hand side, not stable. So this is very important also. This test also determines all the roots on the j omega axis so that their multiplicity can be found out. The polynomial coefficients are arranged in an array called Routh array. So what is the Routh array and sufficient condition? Next step, what is the Routh array or Routh stability criterion? Routh stability criterion. So this is the polynomial equation, fifth order polynomial equation. The Routh array is constructed as follows. Each row is identified in the descending order of power of s. So descending order of power of s. What is the descending order of power of s? The first row contains coefficients of alternate power of rows. S. First row alternate power of s. Suppose this is the s to the power 5, then alternate power cube, and then alternate power s to the power 1. Similarly, for s to the power 4, the alternate power s square, and then s to the power 0. This is the alternate power of s. Then starting with the highest power of s to the power 5. In this case, highest power of s to the power s, this is s to the power 5. This is the starting power. The second row contains coefficients of alternate power of s starting with the second highest power s to the power 4. This is the second highest power. So second row starting, second highest power s to the power 4. The other rows are constructed in a systematic way as indicated in the procedure given below. So this is the sufficient conditions. What is the sufficient condition? So construct the row, arrange all the coefficients of equation 1 in 2 rows. So this is the equation 1, arrange 2 rows. Row number 5 or s to the power 5, this is the coefficients 1 because this coefficients 1, and then alternate coefficients 2 cube, 2 into s cube, and then alternate coefficients 11. So 1, 2, and 11. So first row 1, 2, and 11. Similarly, second s to the power 4, s to the power 4, or row 4, the coefficient, this coefficients 1, and then 2 and 10. So this is the s to the power 4 coefficient, this is s square coefficients, and this is s to the power 0 coefficients, alternate power of s. So these two row very important. Then row 5 and row 4, s to the power 5 and s to the power 4, and step number 4, from these two rows we then subsequent rows to the Routh array. Row 5 s to the power 5, row 4 s to the power 4, row 3 s cube, row 2 s square, row 1 s to the power 1, row 0 s to the power 0. So s to the power 5, row 1, 2, and 11. Write down here 1, next term 2, and next 11. Next 11. Then s to the power 4, 1, 2, and 10. 1, 2, and this is the 10. Then calculate row 3, row 2, and row 1, row 0. That means s to the power 3, s square, and s to the power 1, s to the power 0. A, first element A, B, C, D, E, F, G, H, I, J, K, L. So determine A, B, C, D, E, F, G, H, I, J, K, L. So what is the value A? Then calculate A. A equals to, again, A equals to 1 into 2. 1 into 2. 1 into 2. So write down 1 into 2. Minus 1 into 2 again. This is the value 1 into 2. So write down 1 into 2, and the starting value divided by 1. This one. So this is 1. 1 into 2 first. Then again 1 into 2 divided by this value 1. This value 1. So write down here 1. And this is equivalent to 0. Then calculate B. B equals to 1 into 11. B equals to 1 into 11 minus 1 into 11 means this is the starting point. 1 into 11 minus 1 into 10. So write down 1 into 10. 1 into 10 divided by again starting point 1. Starting point, this value s to the power 4, 1. So this is equivalent to again 1. And C equals to what? C equals to 1 into 0. 1 into 0 minus 1 into 0 divided by starting value 1. Suppose this point 1, 0, and this is also 0, and 1 into 0, 1 into 0. So divided by starting magnitude, starting coefficients 1. So this is equivalent to what? This is equivalent to 0 if A equals to 0. So this is the special case 1 and case number 1, because if A equals to 1, what is the magnitude of D? D equals to A into 2. A into 2. D equals to ultimate A into 2, or 0 into 2 minus 1 into B. 1 into B. B equals to 1. B equals to 1. So put here B equals to 1 and divide by 0. This is undefined. This is difficult to see. That's why this type of case is called case number 1 or Routh case 1. This is because in this position Routh criteria fails. So choose the value A positive, and this positive value epsilon tends to 0 but not equals to 0. So next step, first in Routh array, the third element in the first column is 0, already discussed. And the Routh criteria fails. At this stage, this is the Routh table, already discussed, and this position A equals to 0, B equals to 1, C equals to 0, then D equals to undefined, and D, E, F, G, H, I, J, K, all undefined. So for A, B, C, so this is the case number 1, Routh case 1. So then put this position one positive value. What is the positive value? First case, or this is the special case, and this is also called special case 1. So row 5, 4, 3, 2, 1, 0, and the coefficient, and this is the 0, 1. Then what is the first case? The first case, sometimes the first entry in a particular row may turn out to be a 0. In this position, third row, first element 0. Since the calculation of next row entries involves division by these zeros, the process of constructing the Routh array stops there. To overcome this difficulty, the following procedure may be adopted. So what is the process? First case, this is the process. Next step, this is the Routh array, already discussed. Third row, first element 0. First method, what is the first method? Replace the 0 in the row by epsilon. So in this position, replace epsilon, and epsilon positive must be tends to 0. So epsilon tends to 0. Proceed with the construction of the table. Consider the enters of the first column in the third row of the array by letting epsilon tends to 0. So put here epsilon tends to 0, epsilon equals to positive, not equals to 0, but tends to 0. From the positive side, the Routh array is formed as follows. So next, for A equals to epsilon, what is the value of D, E, F, G, H, I, J, K, L? So calculate D for A equals to epsilon. So what is the magnitude of D? D equals to epsilon into 2, epsilon into 2, again epsilon into 2. So write down D equals to epsilon into 2. Next value minus 1 into 1. 1 into 1, again 1 into 1. So write down here 1 into 1 divided by first starting value epsilon. So this is the epsilon, and equivalent to 2 epsilon minus 1 divided by epsilon. This is the value of D, and for D, epsilon tends to infinity, it tends to 0. Put here epsilon tends to 0. The limit to epsilon minus 1 divided by epsilon equals to minus infinity, because this is equivalent to what? Limit epsilon tends to 0, 2 minus 1 by epsilon. 2 minus 1 by epsilon. Put here 2 minus 1 by 0 equals to 2 minus infinity equals to minus infinity. So this is the value of minus infinity. This is the value of minus infinity. Then calculate E. E equals to what? Again epsilon into 10. Epsilon into 10 minus 1 into 0, because epsilon into 10 equals to 1 into 0. Divide by first value epsilon. So put here epsilon, divide by epsilon, and calculate E. E equals to what? E equals to 10. Then calculate F. F equals to epsilon into 0 minus 1 into 0, but because in this position, if this position 0, epsilon into 0 and 1 into 0. 1 into 0 divided by epsilon. So this is also 0. This is also 0. So then calculate Z, H, I, J, K, L. So what is the value of G? So next step, step number 9, calculate the row 1 or s to the power 1, that is Z, H, and L. And row 5 equals to, and row 5 s to the power 5, 1 to 11, row 4 s to the power 1 to 10, row 3 s cube epsilon 1 and 0, and row 2 already calculate D, E, F, and then calculate row 1 s to the power 1. What is the value of G? What is the value of G? What is the value of G? G equals to D into 1, D into 1. So write down D into 1, or D equals to 2 epsilon minus 1 by epsilon. Divided by minus epsilon into E. Epsilon into E divided by D. D equals to 2 epsilon minus 1 by epsilon. So in this case, D equals to 2 epsilon minus 1 by epsilon. Put here D into 1 minus epsilon into E. Epsilon into E. Then calculate, divide by 2 epsilon minus 1 by epsilon. 2 epsilon minus 1 by epsilon. Then what is the value of G? What is the value of G? And limit epsilon tends to 0, 1 minus 10 epsilon square by 2 epsilon minus 1 by, this is equivalent to 1. So Z equals to 1. Then calculate H. H equals to 0, because H equals to what? D into 0 minus epsilon into 0 divided by D. And 0 minus 0 by D equals to 0. Similarly, for I equals to what? I equals to also 0, because D into 0 minus epsilon into 0 by D. Similarly, calculate J, K, and L. So what is the value of J? Next step, step number 10. Calculate the row 0 or s to the power 0, that is J, K, and L. So row 5, s to the power 5, 1 to 11, row 4, s to the power 4, 1 to 10, row 3, s cube, epsilon 1, 0, row 2, s square, D, E, F, and row 1, s to the power 1, G, H, I, row 0, s to the power 0, and then J. What is the value of J? J equals to what? Calculate J equals to Z into E. Z into E. That means Z. This is the value of Z already discussed. 1 minus 10 epsilon square by 2 epsilon minus 1. This is the value of G into E. E equals to 10. And next minus D into H. D equals to, put D and 0, H equals to 0, divided by Z, Z equals to 1 minus 10 epsilon square by 2 epsilon minus 1. So in this case, this value cancel, only 10, because this value also 0. So what is the value of J? J equals to only 10. J equals to only 10. Then calculate K. K equals to 0. K equals to 0. Why? K equals to 0 because Z into 0, D into 0 divided by Z. So K equals to 0. Similarly, L equals to also 0 because Z into 0 minus D into 0 divided by Z. So L equals to also 0. In this case, L equals to also 0. Then, so what is the final table? What is the Routh final table? Put the value A, B, C, D, F, G, H, I, J, K, L and construct the Routh final table. So this is the final table: row 5, row 4, row 3 or S cube, row 2 and row 1, row 0. In this case, this is the final table. In the first column of the Routh array, there are two changes in sign of the element. So what is the first column? This is the first column. In this case, this is positive, epsilon also positive, but this is negative. This is also positive, this is also positive. So sign change positive to negative and negative to positive. Two signs change. That's why two roots right hand side of the S plane. So system unstable. That is plus epsilon 2 minus infinity. Again plus epsilon 2 minus infinity and minus infinity to, this is the minus infinity to minus infinity again plus 1, minus infinity to plus 1. It is concluded that the system has two roots with positive real parts, and as such the system is unstable. So this is the conclusion, system unstable. This is the Routh final table and the polynomial equation, fifth order polynomial equation, unstable because two sign changes, and it is concluded that the system has two roots with positive real parts, and as such system is unstable. So thank you.